Let's talk a little bit about delta G. There are just a couple of equations you're going to need to know for approaching question 4 on problem set 1, and it's a fairly straightforward set of questions, but you want to make sure that you have these equations in order. If you direct your attention to the top left of the screen here, this is the general equation for delta G standard. Now, if you didn't know, you'll see delta G written in 3 ways. Here's delta G. There is delta G standard, or delta G naught, and then there's delta G naught prime. Now, my understanding of it, which has gotten me this far, is that delta G is basically for whatever the condition is. So this is not necessarily standard pressure temperature. This is the reaction is being carried out in a lab, on the moon, whatever. Delta G just refers to that specific reaction, period. So this is just general. Now delta G prime refers to standard temperature and pressure conditions. So we have 1 atmosphere, 25 degrees Celsius, and we're running the reaction under those conditions. This is what the delta G is going to be. And that's delta G naught. And then there's delta G naught prime. Delta G naught prime is standard temperature and pressure, and all the reactants and products are present at 1 mole. One molar concentration. So now we've standardized the temperature, the pressure, and the concentration. Now there's two main ways that we deal with delta G, and these are the 2 equations. This is equation 1, here's equation 2. This one ties delta G to the equilibrium constant, K, which is negative RT ln K, where R is the ideal gas constant, and T is the temperature, and K is the equilibrium constant. There's another equation which uses log instead of natural log, and there's an approximation of a coefficient which you need to use in order to scale your answer properly. You're free to use that if you're familiar with that method, but I've never used it, and I much prefer this one. And I'll show you why in a future video when we go over there's another formula we're going to derive, and it's going to use this. At any rate, the other one ties delta G to enthalpy and entropy. And here, because we're talking about standard conditions, we're talking then also about standard enthalpy and standard entropy. We could also write it as delta G equals delta H. So the non-standard delta H and the non-standard delta S. You can do that as well. Finally, there's a way to calculate delta G non-standard using delta G standard, and that's this equation in the top right here, where you have delta G is equal to delta G standard plus RT ln K. And if you plug those in, you will get the delta G under non-standard conditions. And as long as you use these 3 equations, I think you're in a good position to work out problem set 4. And of course, if you have any questions, always reach out and let us know, and we're more than happy to help.